Okay, on the unit exam of a trig, or maybe in the final exam, you'll be given these type of questions where you're expected to solve for an angle. For example, this example, you need to solve for k. When you're given the other angle, you're given the length of one side and half of the horizontal side. So in order to solve for k, we need either the opposite side of k, or the adjacent, or the hypotenuse, but we're only given the adjacent side. So we need to use a smaller triangle to determine the height of that triangle so that we can derive k by using tan. So let's start with the smaller triangle first. So what we're trying to do is we need to find this length over here. We'll note as y, okay? And that's the opposite side of 20. So opposite of our hypotenuse is going to be sine. So we say sine of 20 degrees is equal to opposite, which is y, over 45. So in order to solve for y, let's multiply both sides by 45. Cancels out. So y is equal to 45 sine of 20 degrees. So if you plug that into the calculator, which we'll do right now, so 45 times by 20 sine is equal to 15.4 degrees. I mean 15.4. 15.4. So we determine the opposite length of that angle of 20, which is equal to 15.4, which is also the opposite length of k. So now we can use this other triangle to determine the angle of k. So in order to solve for angle of k, well, we're given the opposite side and the adjacent side. So opposite over adjacent gives us tan. So we say tan of k is equal to opposite, which is 15.4 over 50. Now in order to solve for the angle of k, well, we divide both sides by tan. And we note that tan in the denominator as tan to the negative 1 of 15.4 divided by 50. Now we'll plug that into the calculator. So we'll go 15.4 divided by 50 equals, and then we'll second function tan, so which gives us, so k is equal to, oops, what was that? 17.1 degrees. So basically, if you know all your trig functions of sine, cosine, or tan, you should be able to derive questions such as this one that I present to you today.